Software is the invisible force driving our modern world. From the apps on our smartphones to the systems managing air traffic, software is ubiquitous. At its core, software is a set of instructions that tell a computer what to do. These instructions, written in various programming languages, form the building blocks of applications, programs, and systems. This is where requirements engineering comes into play, acting as the crucial bridge between the initial vision of a software system and its successful implementation. Requirements engineering is the unsung hero of software development. It's the meticulous process of defining, documenting, and maintaining what a software system needs to do. Think of requirements engineering as the foundation of a skyscraper. Without a clear understanding of what needs to be built, developers are left to make assumptions, leading to miscommunication, delays, and costly rework. Effective requirements engineering bridges the gap between users and developers by meticulously documenting user needs, system constraints, and performance expectations. Requirements engineering ensures that everyone involved is on the same page. Developing software is like conducting a symphony. Each instrument, each note must be perfectly in tune to create a harmonious masterpiece. Similarly, every aspect of a software system must work in concert to deliver a seamless and satisfying user experience. Functional requirements focus on the specific functions a system must perform. Non-functional requirements deal with the qualities of the system rather than its specific actions. Capturing and documenting both functional and non-functional requirements is essential for creating a comprehensive blueprint for software development. The world of software development is no stranger to innovation. Today, artificial intelligence, or AI, is poised to revolutionize requirements engineering. AI-powered tools are transforming the way requirements are elicited, analyzed, and managed. Natural language processing algorithms can now analyze vast amounts of unstructured data to automatically identify and extract key requirements. AI can assist in detecting ambiguities, inconsistencies, and conflicts within requirements documents. By providing a centralized platform for managing requirements, these tools enable real-time collaboration, version control, and traceability. The software development landscape is evolving at an unprecedented pace. Requirements engineering plays a critical role in ensuring that software projects are delivered on time, within budget, and to the satisfaction of all stakeholders. The integration of AI into requirements engineering represents a fundamental shift in how we approach software development. By automating tedious tasks, uncovering hidden insights, and facilitating better collaboration, AI empowers developers to focus on creating innovative and valuable software solutions. As we move forward, it's crucial for organizations and individuals involved in software development to embrace these advancements. By investing in AI-powered tools and fostering a culture of continuous learning and adaptation, we can unlock the full potential of requirements engineering. Imagine embarking on a journey to build a magnificent skyscraper without a detailed blueprint. Similarly, software development requires a meticulous blueprint to guide the creation of complex systems. This blueprint is known as the requirements document, and its creation is the heart of requirements engineering. Requirements engineering is the systematic process of discovering, analyzing, documenting, and managing the requirements for a software system. It's about understanding the problem to be solved, identifying the needs of stakeholders, and translating those needs into clear, concise, and unambiguous specifications. By facilitating communication, fostering collaboration, and ensuring a shared understanding of the project goals, requirements engineering sets the stage for a successful software development journey. When we think about software, we often focus on its functional aspects, what it does, the tasks it performs, the problems it solves. But a truly successful software system goes beyond mere functionality. It needs to be reliable, secure, user-friendly, and adaptable to changing needs. Functional requirements define the specific actions a system must perform. Non-functional requirements focus on the qualities and constraints of the system. It's essential to consider both functional and non-functional requirements from the outset, ensuring that the final system is not only functional, but also robust, reliable, and user-friendly. Requirements engineering is not a one-time event, but rather an iterative journey that unfolds throughout the software development lifecycle. It's a process of continuous discovery, refinement, and validation, adapting to changing needs and incorporating feedback along the way. The requirements engineering process typically involves several key stages: elicitation, analysis and negotiation, specification, validation, and management. This iterative and collaborative process ensures that requirements are continuously refined and validated, reducing the risk of misunderstandings, rework, and project delays. By embracing change and incorporating feedback throughout the development lifecycle, requirements engineering enables the creation of adaptable and resilient software systems. This ensures that the final system remains aligned with user expectations and delivers the intended value. As software systems grow in complexity, so does the challenge of managing their requirements. Requirements management tools provide a centralized repository for storing, organizing, and tracking requirements. These tools often include features like version control, access control, traceability, matrices, and impact analysis capabilities. In addition to specialized tools, various techniques can be employed to improve requirements management, such as use case modeling, data modeling, prototyping, and requirements reviews. By leveraging these tools and techniques, requirements engineers can effectively manage the complexity of modern software systems. This lays the foundation for successful software development projects that deliver value to users and meet business objectives. While tools and techniques play an essential role in requirements engineering, it's important to remember that at its core, requirements engineering is a human-centric process. effective requirements engineering relies heavily on strong communication skills. Requirements engineers need to be skilled communicators, able to listen actively, ask probing questions, and explain complex technical concepts in a clear and concise manner. Collaboration is equally crucial, requiring input and feedback from a wide range of stakeholders. Building strong relationships with stakeholders is essential for successful requirements engineering. By embracing the human element of software development, fostering collaboration, and prioritizing effective communication, requirements engineers can lay the foundation for successful software projects. The AI revolution, transforming requirements engineering. For decades, requirements engineering has relied heavily on manual processes, painstaking documentation, and countless hours of meetings and discussions. While these traditional approaches have served us well, they are not without their limitations. Enter artificial intelligence, a transformative force poised to revolutionize the way we approach requirements engineering, ushering in an era of enhanced efficiency, accuracy, and insight. AI is not about replacing human intelligence, but rather augmenting it, empowering requirements engineers to work smarter, faster, and more effectively. Imagine AI algorithms tirelessly sifting through mountains of data, identifying patterns, and surfacing critical insights that might otherwise go unnoticed. Picture AI-powered tools automating tedious tasks, freeing up requirements engineers to focus on higher-level activities like stakeholder engagement and strategic decision-making. This is not science fiction. It's the reality of AI in requirements engineering today. AI-powered tools are already making their mark, automating tasks like requirements, elicitation, analysis, and validation. These tools leverage natural language processing to understand and interpret human language, machine learning to identify patterns and predict potential issues, and data visualization techniques to present complex information in an easily digestible format. The integration of AI into requirements engineering is not merely a technological advancement. It represents a fundamental shift in how we approach software development. By automating tedious tasks, uncovering hidden insights, and facilitating better collaboration, AI empowers requirements engineers to focus on what truly matters, understanding user needs, mitigating risks, and delivering high-quality software that meets business objectives. NLP, deciphering the language of requirements. One of the most significant challenges in requirements engineering is dealing with the ambiguity and inconsistency inherent in human language. Requirements are often expressed in natural language, which can be interpreted in multiple ways, leading to misunderstandings, errors, and costly rework down the line. This is where natural language processing steps in, providing AI-powered tools with the ability to understand, interpret, and analyze human language, effectively bridging the gap between human communication and machine understanding. NLP algorithms can analyze vast amounts of unstructured text data, such as meeting minutes, emails, user stories, and social media posts, to identify and extract relevant requirements. These algorithms can identify keywords, phrases, and concepts related to requirements, even if they are not explicitly stated. For example, an NLP algorithm might identify a requirement for secure login from a user story that mentions the need to protect sensitive user data. Moreover, NLP can help to identify and resolve ambiguities and inconsistencies in requirements documents. By analyzing the language used, NLP algorithms can detect potential conflicts, missing information, and conflicting terminology, alerting requirements engineers to potential issues early on. This proactive approach helps to prevent misunderstandings, reduce rework, and ensure that requirements are clear, concise, and unambiguous. NLP is also playing a crucial role in improving the accessibility and usability of requirements documents. AI-powered tools can now automatically generate summaries, glossaries, and diagrams from complex requirements documents, making them easier for stakeholders to understand and review. This not only saves time and effort, but also helps to ensure that all stakeholders are on the same page, reducing the risk of miscommunication and project delays. Imagine having a crystal ball that could predict potential problems in your software project before they even arise. While we may not have crystal balls just yet, machine learning is bringing us closer to this reality. By learning from past projects, identifying patterns, and making predictions, ML algorithms are empowering requirements engineers to proactively mitigate risks and improve the quality of software requirements. ML algorithms excel at identifying patterns in large data sets. In the context of requirements engineering, this means analyzing historical project data, such as requirements documents, bug reports, and code repositories, to identify patterns and correlations that indicate potential problems. For example, an ML algorithm might learn that requirements containing certain keywords or phrases are more likely to be associated with defects or delays. Once these patterns are identified, ML algorithms can be used to predict the likelihood of similar problems occurring in new projects. This allows requirements engineers to focus their attention on high-risk areas, allocate resources more effectively, and take proactive steps to mitigate potential issues before they escalate into major problems. Furthermore, ML can assist in prioritizing requirements and identifying those that are most critical to the project's success. By analyzing factors such as stakeholder feedback, business value, and technical complexity, ML algorithms can help prioritize requirements for implementation, ensuring that the most important features are delivered first. The predictive power of ML is revolutionizing requirements engineering, shifting the focus from reactive problem solving to proactive risk mitigation. By learning from the past and anticipating future challenges, ML is helping to ensure that software projects are delivered on time, within budget, and to the satisfaction of all stakeholders. Section 4. The augmented requirements. Engineer AI as a collaborative partner. The integration of AI into requirements. Engineering is not about replacing human expertise, but rather augmenting it. AI-powered tools are not here to take over the role of requirements engineers, but to serve as collaborative partners, empowering them to work smarter, faster, and more effectively. Imagine an AI assistant that can analyze vast amounts of data, identify potential risks, and suggest solutions in real time. Picture an AI-powered collaboration platform that facilitates communication among stakeholders, automatically translates requirements into different languages, and provides personalized recommendations based on user roles and preferences. This is the future of requirements engineering, where AI and human intelligence work in harmony to achieve common goals. AI-powered tools will handle tedious and repetitive tasks, freeing up requirements engineers to focus on higher-level activities like stakeholder engagement, strategic decision-making, and creative problem-solving. This collaborative partnership between humans and AI will lead to a new era of requirements engineering, characterized by enhanced efficiency, improved accuracy, deeper insights, and better collaboration. By embracing AI as a collaborative partner, requirements engineers can unlock new levels of efficiency, accuracy, and insight, ultimately leading to higher quality software that meets the evolving needs of users and businesses alike. Section 1. The dual pillars, functional and non-functional requirements. In the realm of software development, where lines of code transform into intricate systems, requirements serve as the guiding stars, illuminating the path from concept to reality. These requirements, however, are not created equal. They fall into two fundamental categories, functional and non-functional, each playing a crucial role in shaping the final software product. Functional requirements, as their name suggests, define the specific functions that the software system must perform. They describe what the system should do, how it should respond to user inputs, and what outputs it should produce. These requirements are the building blocks of the system's behavior, dictating how users interact with it and what tasks it can accomplish. Non-functional requirements, on the other hand, focus on the qualities and characteristics of the system rather than its specific actions. They address aspects like performance, security, usability, reliability, and maintainability. These requirements are essential for ensuring that the software not only performs its intended functions, but also does so in a way that meets user expectations and adheres to industry standards. Consider a simple e-commerce website. A functional requirement might be the system shall allow users to search for products by keyword, category, or brand. This requirement specifies a particular action that the system must perform. In contrast, a non-functional requirement might be the system shall load each page within 2 seconds. This requirement focuses on the system's performance rather than a specific action. Understanding the distinction between functional and non-functional requirements is crucial for effective requirements engineering. It allows for a comprehensive and balanced approach to software development, ensuring that the final product is not only functional, but also meets the required quality standards and user expectations. Section 2. Functional requirements. Defining the system's actions. Functional requirements form the backbone of any software system, dictating its actions, responses, and overall behavior. These requirements define the specific tasks that the system must perform, essentially answering the question, what should this software do? They are often expressed as specific actions or behaviors that the system must exhibit, such as the system shall allow users to create an account, or the system shall generate a report based on the selected criteria. These requirements are crucial for defining the system's scope and functionality, providing a clear understanding of what the system is intended to achieve. To illustrate further, consider a banking application. Functional requirements for such an application might include user authentication. The system shall allow users to log in using their unique credentials. Account management. The system shall allow users to view account balances, transaction history, and update personal information. Funds transfer. The system shall allow users to transfer funds between their own accounts or to external accounts. Bill payment. The system shall allow users to schedule and pay bills electronically. Customer support. The system shall provide users with access to FAQs, online chat, or email support. These functional requirements clearly outline the core actions that the banking application must perform. They serve as a guide for developers, testers, and other stakeholders, ensuring that everyone understands the system's intended functionality. Section 3. Delving deeper. Categories of functional requirements. Functional requirements can be further categorized into different types, each with its own level of granularity and scope. These categories help to organize and structure requirements, making them easier to understand, manage, and implement. 1. Business requirements. These high-level requirements describe the overall goals and objectives that the software system aims to achieve for the business. For example, a business requirement for an e-commerce platform might be increase online sales by 20% within the next year. 2. User requirements. These requirements focus on the needs and expectations of the system's end users. They describe what users need to be able to do with the system, such as users should be able to search for products using keywords, categories, or filters. 3. System requirements. These requirements specify the functionality of a software system itself, often at a more technical level. They describe how the system should behave in response to specific inputs or events. For instance, a system requirement might be the system shall authenticate user login credentials against the database. 4. Data requirements. These requirements define the data that the system needs to store, process, and manage. They specify the structure, format, and relationships of data entities. For example, a data requirement for a customer relationship management system might be the system shall store customer data, including name, contact information, purchase history, and communication logs. 5. Process requirements. These requirements describe the business processes that the software system needs to support. They outline the steps involved in a particular business process and how the system should facilitate those steps. For instance, a process requirement for an order fulfillment system might be the system shall automatically generate shipping labels and send notifications to customers when an order is shipped. By categorizing functional requirements in this manner, stakeholders can gain a clearer understanding of the system's scope and functionality from different perspectives. This categorization also aids in prioritizing requirements, allocating resources, and tracking progress during the development lifecycle. Section 4. Non-functional requirements. Shaping system characteristics. While functional requirements define what a software system should do, non-functional requirements dictate how it should do it. These requirements focus on the qualities and characteristics of the system, shaping its overall behavior, performance, and user experience. They are crucial for ensuring that the software not only functions correctly, but also meets the required quality standards, user expectations, and regulatory constraints. Non-functional requirements often address aspects such as performance, how fast the system should respond to user requests, how much data it can process, and how well it performs under peak load conditions. Security, how the system protects sensitive data, prevents unauthorized access, and ensures data integrity. Usability, how easy the system is to use, learn, and navigate. This includes aspects like user interface design, accessibility, and error handling. Reliability, how often the system fails, how quickly it recovers from failures, and how reliable its data backups are. Maintainability, how easy it is to modify, update, and troubleshoot the system. This includes aspects like code readability, modularity, and documentation. For instance, a non-functional requirement for an online gaming platform might be the system shall support a minimum of 10,000 concurrent users with an average latency of less than 20 milliseconds. This requirement specifies a performance standard that the system must meet, ensuring a smooth and responsive gaming experience for users. Unlike functional requirements, which are often specific and measurable, non-functional requirements can be more subjective and challenging to define. They often involve trade-offs and require careful consideration of user needs, business goals, and technical constraints. Section 5. Navigating the nuances. Categories of non-functional requirements. Just as functional requirements can be categorized, non-functional requirements also fall into distinct categories, each focusing on a specific aspect of the software system. Understanding these categories helps to ensure that all aspects of system quality are addressed during the requirements engineering process. 1. Product requirements. These requirements relate to the software product itself, such as its performance, reliability, security, and usability. For example, a product requirement might be the mobile application shall be compatible with both iOS and Android operating systems. 2. Organizational requirements. These requirements stem from the policies, standards, and constraints of the organization developing or using the software. They might include requirements related to branding, security protocols, or data privacy regulations. For instance, an organizational requirement might be all user data collected by the system must be handled in compliance with the General Data Protection Regulation, or GDPR. 3. External requirements. These requirements originate from sources outside the development team or organization, such as industry standards, government regulations, or interoperability requirements with other systems. For example, an external requirement for a medical device. Software might be the software must comply with the FDA's regulations for electronic health records. 4. Technical requirements. These requirements focus on the technical aspects of the software system, such as its architecture, platform, compatibility, programming languages, and database technologies. A technical requirement might be the system shall be developed using a microservices architecture. 5. Quality requirements. These requirements define the overall quality attributes of the software system, such as its reliability, maintainability, portability, and scalability. For example, a quality requirement might be the system shall be designed for high availability with a maximum downtime of 5 minutes per month. By categorizing non-functional requirements, stakeholders can gain a more structured and comprehensive view of the system's quality attributes. This allows for a more focused approach to defining, prioritizing, and verifying these requirements, ultimately leading to a higher quality software product. Section 6. Striking a balance. The interplay of functional and non-functional requirements. Functional and non-functional requirements are not mutually exclusive. They are intertwined and interdependent, each influencing the other in shaping the final software product. A deep understanding of this interplay is crucial for effective requirements engineering. Functional requirements define the what of the system, while non-functional requirements shape the how. For example, a functional requirement might state, the system shall allow users to upload files. This requirement specifies an action that the system must perform. However, the quality of this functionality will be influenced by non-functional requirements such as performance, like the file upload process should complete within 5 seconds, security, such as uploaded files should be scanned for viruses, and usability, like the system should provide clear progress indicators during file uploads. Neglecting either type of requirement can have significant consequences. A system that excels in functionality but fails to meet performance or security standards will likely be rejected by users. Conversely, a system that meets all non-functional requirements but lacks essential features will not be useful. The key lies in striking a balance between functional and non-functional requirements. This requires careful consideration of user needs, business goals, technical constraints, and available resources. It also necessitates effective communication and collaboration among stakeholders to ensure that all perspectives are considered and that the final product meets the needs of all parties involved. Requirements engineers play a crucial role in this balancing act. They must facilitate communication between stakeholders, elicit and analyze requirements, and prioritize them based on their importance and impact on the project. By understanding the interplay between functional and non-functional requirements, requirements engineers can guide the development process toward a successful outcome, delivering a software product that is both functional and high quality. Section 1. Building the bridge. The importance of process in requirements engineering. Imagine attempting to build a bridge without a clear plan, a defined process, or coordinated effort. Chaos would ensue. Beams would be misaligned, materials would be insufficient, and the entire structure might collapse before completion. Just as a bridge requires a meticulous engineering process, so too does the development of successful software. This is where the structured framework of the requirements engineering process comes into play. The requirements engineering process provides a roadmap for systematically gathering, analyzing, documenting, and managing the requirements of a software system. It's not a one-size-fits-all approach, but rather a flexible framework that can be adapted to suit the specific needs of each project. Think of it as a set of guiding principles a structured approach to ensure that all stakeholders are heard, all needs are understood, and all requirements are documented with clarity and precision. Without a defined process, requirements engineering can quickly devolve into a disjointed and chaotic endeavor. Requirements might be missed, misunderstood, or poorly documented, leading to costly rework, project delays, and ultimately a software product that fails to meet user needs. The requirements engineering process provides a structured approach to 1. Elicit, systematically gather requirements from stakeholders, ensuring that all voices are heard. 2. Analyze, scrutinize gathered information, identify potential conflicts or ambiguities, and prioritize requirements based on their importance. 3. Specify, document requirements clearly and unambiguously, creating a shared understanding between stakeholders and developers. 4. Validate, ensure that documented requirements accurately reflect stakeholder needs and are free from errors or omissions. 5. Manage, track changes to requirements throughout the software development lifecycle, maintaining consistency and traceability. By following a defined process, requirements engineering transforms into a collaborative and iterative journey, ensuring that the final software product aligns with user needs, fulfills business objectives, and stands as a testament to meticulous planning and execution. Section 2. Elicitation. Unveiling the needs of stakeholders. Imagine trying to solve a complex puzzle without first examining all the pieces. You might try to force fit mismatched edges, only to realize later that you missed a crucial piece hidden from view. Similarly, embarking on software development without thoroughly understanding stakeholder needs is akin to navigating a maze blindfolded. This is where the crucial stage of requirements elicitation comes into play. Elicitation, the initial stage of the requirements engineering process, focuses on uncovering the needs, expectations, and constraints of all stakeholders involved in a software project. It's about asking the right questions, listening attentively, and delving beneath the surface to uncover hidden assumptions or unspoken requirements. Stakeholders can include anyone who has a vested interest in the software system, such as end users, those who will directly interact with the software, customers, those who are paying for the software development, business analysts, those who understand the business processes that the software needs to support, domain experts, those with specialized knowledge in the relevant field, developers, those who will design and build the software, testers, those who will ensure the software's quality. Elicitation employs a variety of techniques to gather information, each tailored to the specific needs of the project and the stakeholders involved. These techniques include interviews, one-on-one conversations to gather detailed information and perspectives, workshops, structured group sessions to brainstorm ideas, resolve conflicts, and reach consensus, surveys, questionnaires to collect information from a larger group of stakeholders, document analysis, reviewing existing documents such as business process models or user manuals to gather information, observation, observing users interacting with existing systems or prototypes to understand their needs and pain points. Effective elicitation requires strong communication and interpersonal skills. Requirements engineers need to be able to build rapport with stakeholders, encourage open dialogue, and facilitate productive discussions. They must also be adept at filtering through large amounts of information, identifying key requirements, and resolving any conflicts or ambiguities. By meticulously gathering and analyzing stakeholder input, elicitation lays the groundwork for a successful software project, ensuring that the final product aligns with user needs and fulfills business objectives. Section 3. Specification: crafting a blueprint for software development. Imagine an architect trying to explain a building's design using only hand gestures and vague descriptions. Construction would be a nightmare. Just as a blueprint provides a detailed visual representation of a building, requirement specification in software engineering creates a clear, concise, and unambiguous blueprint for developers to follow. Specification, the next crucial stage in the requirements engineering process, involves documenting the elicited requirements in a structured and comprehensive manner. This documentation serves as a shared understanding between stakeholders and developers, a reference point for design and development, and a basis for testing and validation. The choice of specification techniques depends on the project's complexity, the stakeholders involved, and the organization's preferred methodologies. Common techniques include natural language, using plain language to describe requirements, often supplemented with diagrams or tables for clarity. User stories, short, simple descriptions of a feature from a user's perspective, typically following the format. As a user role, I want to goal so that benefit. Use cases, detailed descriptions of how users interact with the system to achieve specific goals, outlining different scenarios and system responses. Data models, diagrams that represent the structure, organization, and relationships of data within the system. Process models, diagrams that illustrate the flow of activities, decisions, and data within a business process that the software supports. Effective requirements specifications are characterized by clarity. Requirements are expressed in a clear, concise, and unambiguous manner, leaving no room for misinterpretation. Completeness. All necessary requirements are captured, leaving no gaps or ambiguities. Consistency. Requirements do not contradict each other and are aligned with overall project goals. Traceability. Requirements are linked to their source, such as stakeholder or business need, and to other related artifacts like design documents and test cases. Testability. Requirements are specific and measurable enough to allow for verification through testing. A well-crafted requirement specification is more than just a document. It's a living artifact that evolves throughout the project lifecycle. As new information emerges, feedback is incorporated and priorities shift. The requirements specification is updated to reflect these changes. Section 4. Validation, ensuring accuracy and alignment. Imagine a ship setting sail without first checking its navigation system. It might end up miles off course, wasting time, resources, and potentially facing disaster. Similarly, in software development, failing to validate requirements is akin to embarking on a journey without a reliable map. Validation, a critical stage in the requirements engineering process, acts as the compass and sextant, ensuring that the project stays on course. Validation involves systematically checking the documented requirements to ensure that they accurately reflect stakeholder needs, are free from errors and omissions, and are consistent with business goals and technical constraints. It's essentially a quality assurance step, a meticulous review process to catch potential issues before they escalate into costly problems during development, or worse yet, after deployment. Validation techniques include reviews, formal or informal inspections of requirements, documents by stakeholders, developers, and testers to identify errors, omissions, inconsistencies, or ambiguities. Prototyping, creating a simplified version of the software system or specific features to gather feedback, validate design choices, and identify potential usability issues early on. Model checking, using automated tools to verify the consistency and completeness of formal requirements models, such as state machines or decision tables. Acceptance testing, involving stakeholders in testing the software against the agreed upon requirements to ensure that it meets their needs and expectations. Effective validation requires a collaborative approach involving stakeholders, developers, and testers throughout the process. It's not a one-time event, but rather an iterative cycle, with validation activities occurring throughout the requirements engineering process and continuing into the development lifecycle. The benefits of thorough validation are manifold. Reduce rework, identifying and resolving errors or ambiguities early in the process prevents costly rework later on. Improve quality, ensuring that requirements are accurate, complete, and consistent leads to a higher quality software product. Increase stakeholder satisfaction, involving stakeholders in the validation process ensures that their needs are met and their expectations are managed. Reduced risk, identifying and mitigating potential problems early on reduces the overall risk of project failure. By meticulously validating requirements, software development teams can navigate the complexities of software engineering with greater confidence, knowing that the project is built on a solid foundation of accurate and aligned requirements. Section 5. Management. Navigating the evolving landscape of requirements. Imagine a bustling city without traffic lights, crosswalks, or traffic laws. Chaos would reign. Similarly, in the dynamic world of software development, where requirements can change as quickly as rush hour traffic, effective requirements management is essential to maintain order and ensure project success. Requirements management encompasses the activities involved in tracking, controlling, and communicating changes to requirements throughout the software development lifecycle. It's about recognizing that requirements are not static artifacts, but rather dynamic entities that evolve as new information emerges, priorities shift, and the project progresses. Effective requirements management involves version control, tracking different versions of requirements documents to maintain a history of changes, identify the latest version, and revert to previous versions if necessary. Change management, establishing a structured process for requesting, reviewing, approving, and implementing changes to requirements, ensuring that all changes are documented, justified, and communicated to relevant stakeholders. Traceability, maintaining links between requirements and other related artifacts such as design documents, test cases, and code modules to understand the impact of changes, facilitate impact analysis, and ensure consistency across the project. Communication. Establishing clear communication channels and protocols to keep stakeholders informed about changes to requirements, solicit feedback, and address any concerns. Requirements management can be a complex endeavor, especially in large projects with numerous stakeholders and rapidly evolving requirements. Thankfully, a variety of tools and techniques are available to assist with this process, including requirements, management tools, specialized software applications that provide functionalities for storing, organizing, managing, and tracking requirements, often integrated with other software development tools. Configuration management systems, tools that manage changes to software artifacts, including requirements documents, ensuring that only authorized changes are made and that all changes are tracked and documented. Collaboration platforms, tools that facilitate communication and collaboration among stakeholders, providing features such as document sharing, version control, and discussion forums. Effective requirements management is crucial for maintaining consistency, ensuring that changes to requirements are implemented consistently across all project artifacts, reducing risks, identifying and mitigating the risks associated with changing requirements, such as scope creep, cost overruns, or project delays, improving communication, keeping stakeholders informed about changes to requirements, and providing a mechanism for feedback and collaboration. Enhancing project success by effectively managing the evolving landscape of requirements. Software development teams can increase the likelihood of delivering a high-quality product that meets stakeholder needs and fulfills business objectives. Section 6. The iterative cycle, embracing change and continuous improvement. Imagine a sculptor approaching a block of marble with the expectation of creating a masterpiece in a single attempt. It's highly unlikely. The true artistry lies in the iterative process, the constant refinement and reshaping until the vision takes form. Similarly, the requirements engineering process embraces an iterative approach, acknowledging that requirements are not static, but rather evolve throughout the software development lifecycle. The iterative nature of requirements engineering is reflected in the interconnectedness of its stages. Elicitation, specification, validation, and management are not linear steps, but rather cyclical phases, each informing and influencing the others. This iterative cycle is essential for accommodating change, recognizing that requirements are not set in stone and that changes are inevitable as the project progresses. New information emerges and priorities shift, incorporating feedback, gathering feedback from stakeholders throughout the process, and using that feedback to refine and improve requirements. Reducing risk, identifying and addressing potential issues early on, minimizing the impact of changes, and reducing the risk of costly rework later in the project. Enhancing collaboration, fostering a collaborative environment where stakeholders and developers work together to refine and validate requirements iteratively. The iterative cycle begins with elicitation, where initial requirements are gathered. These requirements are then specified, validated, and managed. As the project progresses, new information may come to light. stakeholders may revise their needs, or technical constraints may necessitate changes. This new information triggers a return to the elicitation phase, where requirements are revisited, refined, and the cycle begins anew. The iterative nature of requirements engineering demands flexibility and adaptability. It requires a mindset that embraces change as a natural part of the process and views each iteration as an opportunity for improvement. By embracing this iterative cycle, software development teams can navigate the complexities of software engineering with greater agility, responsiveness, and ultimately a higher likelihood of delivering a successful product that meets the evolving needs of its stakeholders.
1, 2, 3.
Section 1. The language of precision. Crafting unambiguous requirements. Imagine a chef trying to follow a recipe that calls for a pinch of salt or a dash of pepper. The results would be unpredictable, to say the least. Just as culinary arts demand precise measurements, so too does the art of software development rely on the language of precision when crafting requirements. In the world of software, ambiguity is the enemy of clarity, and clarity is the cornerstone of successful implementation. Each requirement must act as a beacon, guiding developers towards a shared understanding of what needs to be built. Vague language, subjective interpretations, and hidden assumptions can lead to costly misunderstandings, rework, and ultimately a software product that falls short of expectations. Consider a requirement that states the system should be user-friendly. While well-intentioned, this statement lacks the precision needed to guide development effectively. What constitutes user-friendly can vary widely depending on the user's experience, expectations, and the specific context of the software's use. Instead, strive for requirements that are specific. Clearly define what the system must do, avoiding vague or subjective terms. Measurable. Use quantifiable metrics whenever possible to provide objective criteria for evaluation. Achievable. Ensure that requirements are realistic and attainable within the given constraints of time, resources, and technology. Relevant. Focus on requirements that directly address user needs and business objectives, avoiding unnecessary features or complexities. Time-bound. Specify any time constraints or deadlines associated with the requirement, especially for time-sensitive functionalities. For instance, instead of user-friendly, a more precise requirement might be users shall be able to complete a purchase transaction within 3 clicks without requiring assistance from a customer support representative. This revised statement clearly defines the desired outcome, the acceptable number of steps, and the metric for success. No customer support needed. Section 2. The hallmarks of quality. Essential attributes of effective requirements. In the intricate tapestry of software development, requirements serve as the individual threads woven together to create a cohesive and functional whole. Just as the strength of a tapestry depends on the quality of its threads, the success of a software project hinges on the quality of its requirements. But what exactly constitutes a quality requirement? It's not merely the absence of errors or ambiguities. It's the presence of essential attributes that elevate a requirement from a vague notion to an actionable blueprint for development. Effective requirements exhibit the following hallmarks: Clarity requirements are expressed in clear, concise, and unambiguous language, leaving no room for misinterpretation. Each word should have a specific meaning, avoiding jargon, technical terms, or ambiguous phrases that could be understood in multiple ways. Completeness. All necessary information is included, leaving no gaps or unanswered questions. Requirements should fully describe the desired functionality, including inputs, outputs, processing steps, and any constraints or dependencies. Consistency. Requirements do not contradict each other and are aligned with overall project goals and constraints. They should form a cohesive and harmonious whole, ensuring that different parts of the system work together seamlessly. Traceability. Each requirement is linked back to its source, such as a specific stakeholder need, business objective, or regulatory requirement. This traceability ensures that all requirements are justified and aligned with the project's overarching goals. Testability. Requirements are specific and measurable enough to allow for verification through testing. They should define clear acceptance criteria that can be objectively evaluated to determine whether the requirement has been met. These attributes are not mere checkboxes on a requirements document. They are guiding principles that should permeate every aspect of the requirements engineering process. By striving for clarity, completeness, consistency, traceability, and testability, software development teams can lay the foundation for a successful project, minimizing misunderstandings, reducing rework, and ultimately delivering a software product that meets or exceeds stakeholder expectations. Section 3. From ambiguity to clarity. Techniques for writing better requirements. Imagine trying to build a house using a blueprint sketched on a napkin. The result would be disastrous. Just as architects rely on precise drawings and detailed specifications, software developers need clear, unambiguous requirements to guide their work. Transforming ambiguous ideas into actionable requirements is both an art and a science, requiring a keen eye for detail, a deep understanding of the problem domain, and effective communication skills. Here are some practical techniques to elevate your requirements from vague notions to crystal clear specifications. First, use active voice and strong verbs. Instead of saying, the system shall provide the ability to write, the system shall generate, or the user shall be able to. Active voice and strong verbs make requirements more concise and easier to understand. Next, avoid ambiguous language. Words like approximately, usually, or as soon as possible are open to interpretation. Instead, use specific values or ranges whenever possible. For instance, instead of the system should respond quickly, write the system shall respond to user requests within 2 seconds. Break down complex requirements. If a requirement seems too broad or complex, break it down into smaller, more manageable sub-requirements. This not only improves clarity, but also makes requirements easier to test and implement. Use visual aids. Diagrams, flowcharts, and mock-ups can often convey information more effectively than text alone. Visual aids can help to illustrate complex processes, clarify relationships between different parts of the system, and provide a shared understanding among stakeholders. Involve stakeholders in reviews. Don't write requirements in isolation. Share drafts with stakeholders early and often to to gather feedback, identify ambiguities, and ensure that the requirements accurately reflect their needs. Use a consistent template or format. A standardized template or format for requirements documents can improve readability, consistency, and ease of maintenance. It also helps to ensure that all necessary information is included and organized logically. Remember, writing clear requirements is an iterative process. Don't be afraid to revise, refine, and seek feedback throughout the process. The effort invested in crafting precise and unambiguous requirements will pay dividends throughout the software development lifecycle, reducing misunderstandings, minimizing rework, and ultimately leading to a higher quality software product. Section 4. The AI advantage, leveraging technology to enhance requirements. Quality. In the realm of software development, where precision and clarity reign supreme, artificial intelligence is emerging as a powerful ally in the quest for higher quality requirements. No longer confined to the realm of science fiction, AI-powered tools are transforming the way requirements are written, analyzed, and managed, offering a glimpse into a future where ambiguity fades and clarity prevails. Imagine an AI assistant that tirelessly scrutinizes your requirements documents, flagging potential issues like ambiguity, inconsistency, or incompleteness in real time. Picture an AI-powered platform that analyzes vast amounts of project data, identifying patterns and suggesting improvements to requirements based on best practices and lessons learned from past projects. This is not a futuristic fantasy, it's the reality of AI in requirements engineering today. Here's how AI is transforming the landscape. Automated requirements analysis. AI-powered tools can analyze natural language requirements documents, identifying potential issues like ambiguity, inconsistency, or incompleteness. These tools use techniques like natural language processing and machine learning to understand the meaning and intent behind human language, flagging potential problems that might otherwise go unnoticed. Requirements. Quality prediction. By analyzing historical project data, AI algorithms can identify patterns and correlations that indicate the likelihood of defects or rework based on the quality of requirements. This allows teams to focus their attention on high-risk areas and proactively improve requirements before they escalate into costly problems. Automated requirements generation. In some cases, AI can assist in generating requirements automatically from other sources of information, such as user stories, design documents, or even code. This can save time and effort, especially for repetitive or standardized types of requirements. Requirements, traceability, and impact. Analysis. AI can help to automatically track relationships between requirements and other project artifacts, such as design documents, test cases, and code modules. This traceability enables teams to understand the impact of changes, assess risks, and ensure consistency across the project. Requirements, collaboration, and communication. AI-powered platforms can facilitate communication and collaboration among stakeholders involved in the requirements engineering process. These platforms can provide features like real-time chat, document sharing, version control, and automated notifications, streamlining communication and ensuring that everyone is on the same page. By embracing the power of AI, software development teams can elevate the quality of their requirements, reduce ambiguity, minimize rework, and ultimately deliver software products that meet or exceed stakeholder expectations. As AI technology continues to evolve, its impact on requirements engineering is only set to grow, paving the way for a future where clarity, precision, and efficiency become the hallmarks of software development. Section 1. The enduring significance of requirements engineering. As we conclude our exploration of requirements engineering, it's crucial to reiterate its enduring significance in the ever-evolving landscape of software development. In an industry often characterized by rapid innovation, shifting paradigms, and the relentless pursuit of the next technological leap, requirements engineering stands as a steadfast pillar, grounding software projects in the bedrock of user needs, business objectives, and technical realities. It's tempting to view requirements engineering as a mere stepping stone, a preliminary hurdle to overcome before diving headfirst into the exhilarating world of coding, design, and deployment. However, this perspective belies the profound impact that well-defined, meticulously crafted requirements have on the overall success of a software project. Requirements engineering is not simply a phase to be completed, but rather a mindset to be embraced, a continuous process that permeates every stage of software development. It's about fostering a deep understanding of the problem being solved, the users being served, and the value being delivered. It's about bridging the communication gap between technical teams and business stakeholders, ensuring that everyone is speaking the same language and striving towards a shared vision. In essence, requirements engineering is the compass and map guiding software projects through the often treacherous terrain of development. It provides direction, ensures alignment, and minimizes the risk of veering off course into the wilderness of costly rework, missed deadlines, and ultimately a software product that fails to meet its intended purpose. Section 2. Embracing the AI advantage, a new era of software development. As we stand at the cusp of a new era in software development, one shaped by the transformative power of artificial intelligence, it's essential to recognize the profound impact this technology is having on the practice of requirements engineering. AI is not merely automating tasks, it's augmenting human intelligence, empowering requirements engineers to work smarter, faster, and with greater insight than ever before. Imagine a world where AI algorithms can sift through mountains of data, identifying patterns, surfacing hidden insights, and flagging potential issues in real time. Picture AI-powered tools that can analyze natural language requirements, documents, identify ambiguities, and suggest improvements based on best practices and lessons learned from past projects. This is not science fiction, it's the reality of AI-driven requirements engineering today. AI is transforming the way requirements are elicited, analyzed, specified, validated, and managed, ushering in an era of enhanced efficiency, accuracy, and collaboration. Here are just a few ways AI is revolutionizing requirements engineering. Automated requirements analysis. AI algorithms can analyze natural language requirements documents, identifying potential issues like ambiguity, inconsistency, or incompleteness, effectively acting as tireless guardians of clarity and precision. Requirements, quality, prediction. By analyzing historical project data, AI can predict the likelihood of defects or rework based on the quality of requirements, enabling teams to proactively address potential problems before they escalate into costly delays. Automated requirements. Generation AI can assist in generating requirements automatically from other sources of information, such as user stories, design documents, or even code, freeing up human engineers to focus on higher level tasks. Requirements. Traceability and impact analysis. AI can automatically track relationships between requirements and other project artifacts, enabling teams to understand the impact of changes and ensure consistency across the entire software development lifecycle. Requirements, collaboration, and communication. AI-powered platforms can facilitate communication and collaboration among stakeholders, streamlining communication, ensuring that everyone is on the same page, and fostering a more collaborative and efficient requirements engineering process. By embracing the power of AI, software development teams can unlock new levels of efficiency, accuracy, and insight, ultimately delivering higher quality software that meets the evolving needs of users and businesses alike. Section 3. The Journey Ahead. Navigating the future of software with confidence. As we look to the future of software development, one characterized by increasing complexity, accelerating innovation, and the relentless pursuit of digital transformation, the role of requirements engineering will only become more critical. The software systems of tomorrow will need to be more adaptable, resilient, and intelligent than ever before, and their creation will demand a rigorous and disciplined approach to requirements engineering. The journey ahead will be marked by both challenges and opportunities. The rise of new technologies, such as artificial intelligence, blockchain, and the Internet of Things, will create new complexities and demand new approaches to requirements engineering. At the same time, these technologies will also provide new tools and techniques for enhancing the efficiency, accuracy, and effectiveness of the requirements engineering process. To navigate this evolving landscape successfully, software development teams must embrace a mindset of continuous learning and adaptation. They must stay abreast of emerging trends, experiment with new tools and techniques, and be willing to challenge existing assumptions and paradigms. Here are a few key takeaways to guide the journey ahead. Embrace the human element. While technology will undoubtedly play an increasingly important role in requirements engineering, it's crucial to remember that at its core, requirements engineering is a human-centric process. It's about understanding the needs of people, fostering collaboration, and communicating effectively. Focus on value. Requirements should not be viewed as mere checkboxes on a list, but rather as opportunities to deliver value to users and businesses. Every requirement should be justified by its contribution to the overall goals of the project. Embrace change. The only constant in software development is change. Requirements will inevitably evolve throughout the project lifecycle, and teams must be prepared to adapt, iterate, and refine their approach accordingly. Leverage the power of AI. AI is transforming the practice of requirements engineering, offering unprecedented opportunities to enhance efficiency, accuracy, and insight. Embrace the power of AI, but do so thoughtfully and strategically, ensuring that it complements and enhances human expertise. Never stop learning. The field of requirements engineering is constantly evolving. Make continuous learning a priority, staying abreast of emerging trends, experimenting with new tools and techniques, and seeking out opportunities to expand your knowledge and skills. By embracing these principles and approaching the future of software development with a spirit of collaboration, innovation, and a commitment to excellence in requirements engineering, we can navigate the challenges ahead with confidence, delivering software solutions that meet the needs of today and unlock the possibilities of tomorrow.